Hi guys, and welcome back to Math Board. So now we'll be looking at the product rule, and under that questions. So first question, y equals x squared root 3x minus 1. So now under product rule we have learned when this is going to be u and this is going to be v, dy by dx is going to be v du by dx plus u dv by dx. So this is the basic product rule and we're going to apply that. So if we look at this first, the u is a function where u is equal to x squared, v is root 3x minus 1. So to find dv by dx, at this moment we cannot differentiate this root 3x minus 1, since root 3x minus 1 is same as 3x minus 1 to the power half. So we do not know that actually. So to find the differentiated version of that, we use the chain rule. So we'll let this, so this is v equals that. So now we use chain rule to find dv by dx. The rest you can find, since we know du by dx is the differentiated version of x squared, and u is going to be x squared, and dv by dx, which is what we are going to find now. So now v is equal to 3x minus 1, everything to the power half. So first step you do, we let 3x minus 1 equals to a constant such as t. So v is equal to t to the power half. So dv over dt is going to be half t to the power minus half, which is equal to half 3x minus 1 to the power minus half. And that is the dv by dt. So according to chain rule, dv by dx is going to be dv over dt into dt over dx. So we find dt over dx 2, which is going to be 3. When you differentiate 3x minus 1, you end up with 3. So according to the chain rule, dv over dx is going to be dv by dt into dt by dx, which is going to be dv over dt is going to be this, and dt by dx is going to be 3. So finally it's going to be 3 over 2, 3x minus 1 to the power minus half, and that is going to be dv by dx. So now we found the differentiated version of v using the chain rule. So now let's apply the product rule for this. So dy by dx is going to be v is going to be 3x minus 1 to the power half multiplied by du by dx. du by dx is going to be the differentiated version of x squared. So when you differentiate x squared, you're going to end up with 2x plus u is going to be x squared multiplied by dv by dx. dv by dx is going to be this 3 over 2, 3x minus 1 to the power minus half. So we're going to end up with, when we simplify this, so 2x 3x minus 1 to the power half plus 3 over 2 x squared 3x minus 1 to the power minus half. So now we can take some factors out of this, so we can write this as 2x and root 3x minus 1 and plus 3x squared divided by 3x minus 1 to the power half. So this we can write as 2x root 3x minus 1, and this plus 3x squared divided by 2 root 3x minus 1. So for further simplification, we can multiply top and bottom of this by the denominator of this. So then we're going to end up with this is going to be 4x and 3x minus 1 plus 3x squared divided by 2 root 3x minus 1. So we're going to simplify this further. So when we expand this bracket, it's going to be 12x squared minus 4x plus 3x squared divided by 2 root 3x minus 1. So when we add these two are going to end up with 15x squared and minus 4x divided by 2 root 3x minus 1. So that's the solution for the first question we did under differentiation. So the next question that we have is y is equal to e to the power 4x into sine squared 3x. So now everybody knows how to differentiate e to the power 4x, but sine squared, some sine we know the differentiation answer, but sine squared do we know? At the moment no, so we're going to find it using the chain rule. So firstly we're going to label the two. This is going to be u and this is going to be v. Since it's a multiplication, so we're going to use product rule now. So what we need to find, we'll just summarize and see. So dy by dx is going to be v into du by dx plus u into dv over dx. So v is going to be sine squared 3x, du by dx we can find by differentiating this, and u we know, dv by dx we have to find using the chain rule. So now first thing we'll do is find du by dx. So u is equal to e to the power 4x, so du by dx is going to be, when you differentiate e to the power ax, where a could be any number, so here it's e to the power 4x, 4 comes to the front and e to the power 4x, since it's this format when we differentiate e to the power 4x. So we know v, we know du by dx, we know u. Now we have to find dv over dx. So to find dv over dx we use the chain rule. So in that process, first thing we're going to label v. V is going to be sine squared 3x. So in the same process as previously, we're going to let sine 3x equals t, where t is any letter. So v is going to be t squared, where dv by dt is going to be 2t, which is going to be 2, where t is going to be sine 3x, so here I can put sine 3x. So we found dv over dt. Now to find dt by dx, we just differentiate sine 3x. So when you differentiate sine 3x, you get 3 cos 3x. So it's going to be 3 cos 3x. Now we found dv over dt and dt by dx. So the thing we need to find is dv by dx, which is equal to dv over dt into dt by dx. So this is equal to 2 sine 3x multiplied by 3 cos 3x, which is going to be 6 sine 3x cos 3x. So now we found dv by dx as well. So to find dy by dx, we just have to put all the values and substitute them accordingly. So dy by dx is going to be v. V is going to be sine squared 3x multiplied by du by dx, which is going to be 4 e to the power 4x, plus u is going to be e to the power 4x, and dv by dx is going to be 6 sine 3x cos 3x. So this is equal to 4 e to the power 4x sine 3x squared plus 6 e to the power 4x sine 3x cos 3x. So we can take sine 3x out along with e to the power 4x. So e to the power 4x sine 3x. When we factorize this, so 4, we're going to end up with 4 sine 3x plus 6 cos 3x. So that's that, and we found the solution.